So, welcome back, students. Today, our topic is endogenous process and associated landforms. Now, this chapter we are going to divide into two parts, part one and part two. In part one, we are going to discuss about the different forces of endogenous processes, folding and faulting. Now, before starting, now what are landforms or how does they looks like? The landforms are plateaus, mountains or plains. Now these landforms over the surface, they are nothing but general structures on the land. They are nothing but some structures over the land which are developed by different natural processes. Now why only natural processes? Because the landforms like mountains or plateaus, they are these features cannot be developed by human beings. So let us start. The landform on the Earth's surface are ever changing. They always keep on changing from time to time. The landforms on the Earth's surface are always keep on changing from time to time under the influence of two forces. Okay, under the influence of two forces. They are endogenic forces and exogenic forces. Now, what are these endogenic forces and exogenic forces? Endogenic forces are also called the interior forces. Okay, endogenic forces are also called interior forces. Now, these endogenic forces or endogenic processes, they generally take place inside the Earth's surface. Now, these endogenic forces that generally takes place inside the Earth's surface with the help of different, by the help of these forces, the important features such as mountain, plateaus and plains are formed. The mountain, plateaus and plains are formed by which forces? Endogenic forces. Now, endogenic forces is really very important for the development of landforms over the surface of the earth. This is endogenic. Now, what is exogenic forces? The forces which takes place over the earth surface. Okay. The forces which takes place over the earth surface, or you can tell them exterior forces. Now, exogenic forces may be like say erosion by wind, water. Okay. Now, this endogenic forces has been divided into different groups or different parts. Endogenic processes, first of all, has been divided into diastrophism and sudden movement. Then again, diastrophism has been divided into epirogenetic forces or orogenetic forces. Epirogenetic forces has been further divided into upward forces or downward forces, whereas orogenetic forces has been further divided into compressional and tensional forces. Now, what is sudden movement? The movement which takes place suddenly. The movement which takes place suddenly over the surface of the earth. Or say, for example, for sudden movement, example will be, the best example can be earthquake. Okay. Now, let us see diastrophism. Diastrophism is naturally, it is a very slow movement. Okay. Diastrophism is naturally, it is a very slow movement. Now, this diastrophism has been divided into two groups. As I told you earlier, they are epiogenic forces or orogenic forces. Epiogenic forces can also be called vertical forces, whereas orogenic forces can also be called as horizontal forces. Now, let us see epiogenic forces. Epiogenic force always act in vertical direction or in vertical angle. Now, this word epirogenic, okay, this word epirogenic is taken from the Greek word, is a Greek word where epiros meaning continent, okay, epiros meaning continent, and this force epirogenic is mainly involved in continent building. this aperogenic force is mainly involved in continent building. Now, these aperogenic forces can be divided into two types, that is upward force or downward force. Upward force or downward forces. Now, what is upward force? A part of the earth crust rises in relation to its surrounding under these forces. Means upward force, it helps in upliftment of landform. Upward force, it helps in the upliftment of landform, whereas downward forces, it helps in the submergence of landform or subsidence of any landform. Let me tell you again, aperogenic forces can be divided into two, that is upward force or downward force, where upward force is used for upliftment of land surface, whereas downward force is responsible for the subsidence of land surface. Now you can see here, this is a landform. Okay. Now you can see here this part. Okay. This part here, it is located little bit higher, this also higher, and it is below this land surface, isn't it? This is located much below to than this land surface. Now why is it? This is because once upon a time this was a plane surface. Okay, once upon a time this was a plane surface, but due to the upward movement, okay, due to the upward movement or due to the upward force which results in upliftment, okay, this part of the land has gone up. Same here, this part has lifted up. Okay, now this, the parts which have been lifted up has been due to what? Due to vertical forces. Okay, so this is aperogenic force. Now this is an example of aperogenic force where you can see a small island shape, island type came out from the ocean, came out from the ocean, from below the ocean. Next is orogenic forces. Okay. It, now this orogenic forces, it acts horizontally from the sides. It acts from the sides. Now this word orogenic has also been derived from a Greek word where orog meaning mountain. Thus they are helpful for mountain building, or you can say they are mountain building forces acting in a horizontal direction. These movements are responsible for greatly disturbing the horizontal arrangement of rock strata. Now this force, what they do? They disturbs the horizontal arrangement of rock strata. Now this orogenetic forces has been divided into two types, compressional force and tensional force. Okay, compressional force and tensional force. Now what is compressional force? It is a force which push a body from opposite side, from opposite directions, or you can say when you pull, or so sorry, when you push any object, when you push any object from both the sides, okay, when you push any object from the both the side, what will happen? It will start lifting up from the center. It will start lifting up from the centers. For example, here I have tried to show. So this is a landmass, this straight line, this is a landmass, and from this side compressional force is acting, from this side compressional force is acting. Now when this both the forces, these two forces from both the side, when compressional force pushes the landmass, what will happen? The landmass from the middle, it will start uplifting in this way. From the middle, it will start uplifting. So such type of landmass is called what? Folding. This process is called folding, and this is how mountain forms. This is how the mountain forms. Now another force is there, that is called tensional force. Now it is a pulling force. It pulls the landmass from both the sides. Okay, it pulls the landmass from both the sides. So for example, if you take a piece of paper and if you pull it from both the sides, what will happen? It will tear into two pieces. isn't it? If you take a paper and if you try to pull it from both the side, it will tear up into pieces. Same thing is happening here. So this is a landmass. This is a landmass, and the tensional forces originated here as well as here. Now, when these two forces, these two tensional forces, they pull this landmass. They pull this landmass from both the side. What will happen after a certain period of time? A crack will develop in between the landmass. A crack will develop in between this landmass. So this crack is called fault. Okay, this crack is called fault. Tell you again, orogenetic force, it acts horizontally. There are two factors, compressional force and tensional force. Now compressional force, it acts from both the sides, whereas tensional force, it pull the object, it pulls any object or it pulls the landmass. For example, here this is a landmass, you can see here I have drawn, and compressional force are acting from both the side, they are pushing from both the side. Now due to this compressional force, what will happen to this land surface? It will start uplifting. Okay, it will start uplifting and it will form a mounting. Such type of formation is called folding. And another one is here, you can see the tensional force. Same, this is a landmass again, and from both the side tensional forces are occur. Now these tensional forces, what they will do, they will pull this landmass away from each other. They will try to pull from both the side. Now due to this force, when it acts over a longer period of time, what happens, this landmass, it get divided into two part. In this way it get divided into two part and forms a fault. Okay, forms a fault. Now let's see what are folding and folding. First of all, folding. What is this folding? This is nothing but the bending of horizontal layer of rocks. This is nothing but the bending of horizontal layer of rock. Now why is it caused folding? Why is it causing? This is caused due to compressional forces. The foldings are caused due to compressional forces. It happens when two horizontal forces act towards a common point or a place. It acts towards a common point or a place, like waves on the surface of water. Now you can see here, this diagram. Okay, here you can see a flat land. Here it little bit uplifting. Here you can see a upliftment can be easily seen here. Like this is a plain land. This is the plain land. Now after a certain period of time, when these two compressional forces are pushing the landmass from both the sides, when these two compressional forces are pushing the land from both the side, what will happen after a certain period of time? It will start uplifting. The landmass will start uplifting and it will form a mountain. So such upliftment is called folding. Now look here, this is a fold. Okay, this is called a fold in this pattern. Now this part of a fold, this part of the fold is called anticline. Okay, this part of the fold is called anticline, whereas this part, this valley, it is called syncline. Okay, again here it is called anticline. And below this part and this part, they are called the limbs of the fold. Same, this again, the here this part and this is called the limb of the two limbs of the fold. So this is about fold. Now let us see the different types of folds. Now there are different types of fold: symmetrical fold, asymmetrical folds, monoclinal folds, isoclinal folds, recumbent folds, and overthrust folds. First of all, let us see symmetrical folds. What is this? When both the limbs of a fold are equally bent and they are inclined at almost equal angle to the horizontal, it is called symmetrical fold. Now in this symmetrical fold, both the limbs, this and this, both the limbs will be at equal angle. Now if you try to draw a straight line here, and try to find out the angle, both the angle, this angle and this angle, what will be, the angles will be equal. So such type of foldings are called symmetrical fold. Now come to asymmetrical fold. This type of fold is formed when one limb of the fold is pushed too far so that one side of the fold is long and gradual in slope while the other is short and steep. In this type of fold, what happens? One limb is pushed very far. Okay, this limb is far from this, and this limb will be gradual. Okay, it will have a gradual slope, whereas the other limb, it will be short and it will have a steep slope. Okay, and another feature of this type of fold, that is of symmetrical fold, is this is, and this is not having a equal angle. Okay, it's not having a equal angle. In the same way, if you try to draw a line here in the middle, and if you try to find out the angle of both the limbs, you will not find, you will find that the angles are different. So such type of folds are called asymmetrical folds. Next, monoclinal folds. When the compressional force act in such a way that one limb of the fold is vertical, it is called monoclinal fold. Now in monoclinal fold, you can see that the compressional force has acted in such a way that one limb is totally vertical. Isoclinal fold or overfold. Isoclinal folds are also called overfold. When the isoclinal or overfold goes to such an extent, it is formed when fold is pushed over one side so that both the sides of the fold are inclined at the same direction. You can see here the compressional force has taken place in such a way that both the limbs are in the same direction, isn't it? Both the limbs are in the same direction. The short and steep side also dips in the same direction too. Next, recumbent fold. Now, when the isoclinal fold goes to such an extent that one limb is pushed over the other and the two limbs are almost parallel to each other. Now, when recumbent fold is formed, it is formed from isoclinal fold. Okay, when the isoclinal fold has formed, after a certain period of time, the two limbs of the isoclinal fold, these two limbs of the isoclinal folds become parallel to each other in such way. Okay, when isoclinal folds are formed after a certain period of time, both the limbs of the isoclinal fold become parallel to each other in such a way. Here you can see that both the limbs are parallel to each other. So when both the limbs becomes parallel to each other, such type of folds are called recumbent fold. Overthrust fold. In case of acute folding, the pressure of the compressional force is so great that a fracture occurs in the fold. Now here you can see this line, this thrust plane is a fracture in the fold. One side of the limb pushed forward over the other limb along the thrust plane. Now both the limbs, this limb and this one, once they were together, okay, this limb is supposed to be here, but due to the compressional force, what happened, this limb, it pushes forward, it has gone forward. So such type of folds are called overthrust folds. So this is all about folds. Now let us see faulting. Now, as compressional result in folding, foldings are caused due to the compressional force. In such a way, faulting is caused due to the tensional force. As the force of tension increases in the earth crust, a stage comes when the rock strata cannot withstand the force and the rock breaks. Okay, as the force of tension keep on increasing in the earth crust, a stage comes or a time comes when the rock, it cannot hold or it cannot bear the stress anymore. Okay, it cannot bear the tension anymore. So what happened, the rock break into pieces, rocks break into pieces. Now there are few terms like fault plane, down thrown side, up thrown side, and fault step. What are they? First of all, fault plane, the plane along which the fault takes place. Now you can see here this one, this is a block of a rock. Now can you see this line where I have marked one? This is called fault plane. Okay, this is the place along which the fault will takes place. This is the place along which the fault will takes place or breaking will take place. Next come fault scrap. This angle, okay, this angle is called fault scrap, the part which is exposed as a result of faulting. Now when this faulting takes place, this part of the block or this part of the mountain, it will be upstanding, standing still, and this section it will slip down. Okay, this section it will slip down, exposing this part, exposing this part of this section. This is called fault scrap. Now next is down thrown side. What is down thrown side? The down thrown part. Now here when the faulting took place, what happened? This part was standing still, I told, and this part it came down. Okay, here you can see this part has came down. So this is called down thrown side, and the part which is hanging up, okay, which is standing in its own position, it is called up thrown side. So this is called upthrown side. Now there are different types of faults. From the point of view of position and movement, fault can be of following types: normal fault, reverse fault, thrust fault, and steep fault. First of all, let us see normal fault. In a normal fault, the blocks on either side of the plane move in opposite direction because the force of tension acts in opposite direction. Now you can see here this block, what is happening here? Due to the force of tension, they are moving away from each other. Through the arrow you can see they are moving away from each other. The hanging wall slips downward. The fault plane is either vertical or has a very steep slope. You can see here the hanging wall. This is the hanging wall and it slips downward. Okay, it slips downward, and the fault plane, this is fault plane, it will be either vertical or it will be a very steep slope. Okay, such conditions are called normal fault. Now next one is reverse fault. The fault is produced by compression. We know that faults are generally produced due because of tensional force, but in case of reverse fault, it is opposite. It is caused due to the compressional force, because of compression. In such a fault, the blocks along the fault line move towards each other. Now you can see here, this is the fault line. Okay, this pointed portion, this is the fault line. Okay, now from this fault line, both the blocks are coming close to each other. They are moving towards each other. The hanging wall slips up. The slope of the fault plane is gentle. Here you can see here, this was the hanging wall. The hanging wall has been lifted up. Okay, the hanging wall has been lifted up, and the fault scrap. Okay, this fault scrap, it will be gentle. Okay, now if you compare of this normal fault and reverse fault, you can see the normal fault is having a steep fault scrap, whereas reverse fault is having a gentle fault scrap. The next one is thrust fault. When one block of the fault rises up the other along the fault plane, it is known as thrust fault. Now this black line you can see, this is called the thrust fault. Okay, sorry, this is called fault plane. Okay, what is this called? This black line, it is called fault plane. Now when due to the tensional forces, when one block, okay, there are two blocks, this is one block, this is another block, when due to the tensional forces one block is pushed forward, along the fault line, such type of faults are called thrust fault. Okay, the last one is steep fault. When an area suffers several parallel faults, when in any area there are several faults, okay, several parallel faults. You can see here parallel faults. There are 1, 2, 3, 4, 5 parallel faults. When in any area there are several parallel faults, the crust is broken into thin strata. The crust is broken into thin strata, and the slope in one side is in one side. Now you can see here in this parallel faults, okay, in this parallel faults, the slope is in this way, isn't it? The slope is in one way, not in both the sides. The slope is only in one way. Here the faults look like a stairs. Here in steep fault, you'll find the faults, it looks like stairs. These are the faults. 2, 3, 4, 5. Now you can see it looks like a staircase, isn't it? So such type of faults are called steep fault. Let me tell you again, when in any area we have several parallel faults, okay, several parallel faults in such a way that the crust is broken into thin strata or in thin particles. Okay. The in such case, this parallel faults, the slope will be on one side. The slope you can see it is only in one side here, isn't it? The slope is over this side. So the fault it looks like a staircase. Now here you can see in this parallel faults the faults. These are the faults I have told you. These are the faults. It looks like a stair of a building, isn't it? So such type of faults are called steep fault. So this is all about this part where you have studied the endogenic process, the different forces of endogenic and folding. What is folding? How is it formed? How is it caused? And what are the different types of faults? Faulting. What is faulting? And different types of faulting. In the next part, we'll discuss about different landforms formed due to endogenous processes like mountains, plateaus, and plain, their classification, and the relationship between mountain and man, mountain and man, plateau and plain and man, their relations. So, thank you. I hope you will understand.